This presentation covers the evaluation of a ferry terminal wait time and queue length study. This study occurred on the Outer Banks of North Carolina between the communities of Hatteras and Ocracoke. Shown in the solid circle, the ferry route is a free ferry that operates on the northern end of Ocracoke and connects the community of Hatteras. The island of Ocracoke is also connected to the mainland through two tolled ferries at the southern side of the island. From 1999 to 2015, several events have occurred that have decreased the ridership between Hatteras and Ocracoke. So if we look at yearly volumes, the top line here, we can see Hurricane Floyd, Isabel, the recession, Hurricane Irene, and the remnants of Superstorm Sandy all affected the ridership over that time period. And there was a change to the current route which occurred in 2013. Prior to that time period, there were 53 daily crossings in each direction. Those decreased to 36 after the change, and that's because the route changed from a shorter 40-minute route to approximately a 60-minute route, and we'll see an image of that coming up. There are 7 ferry vessels that serve the route, and those ferries have a capacity of approximately 26 vehicles. The longer route also adds additional fuel costs and labor costs that total about $7,000 per day. And feedback from local business owners indicated that they have seen a 20 to 25% loss in revenue, which is attributed to fewer daily visitors due to the decreased ferry service and the longer travel time to Ocracoke. In 2015, the Ferry Division commissioned a study that this evaluation was part of to examine the feasibility of options to meet the current and forecasted demand for visitors to Ocracoke and to increase the level of service on the Hatteras-Ocracoke route. The traditional route between the Hatteras Terminal and the South Dock Terminal, which is again at the northern end of Ocracoke Island, is shown in red, that goes through the Inlet Gorge. And after the storm realigned the channel, the horseshoe channel has been used. So you can see the shorter or straighter path was about a 40-minute trip, and then along the green line through the horseshoe channel was approximately 60 minutes. Also shown are a couple of alternatives along the Rawlinson Channel and to Silver Lake Harbor, which would connect the Hatteras Terminal to the southern end of Ocracoke Island, more directly in the village of Ocracoke. But currently, in terms of connecting to South Dock, the Horseshoe Channel is being used, and that's an approximately 60-minute ferry route. This image shows vehicles queued to board the ferry at Hatteras. Increasing ferry service frequency is a possible solution for decreasing the wait times that peak season visitors may expect. However, in a fiscally constrained environment, adding service may not be viable, and also just in terms of capacity of the channel itself and the terminal facilities, it's only possible to increase service to a certain level. There are other things that can be done to improve the quality of the waiting experience. Queue psychology suggests there are a number of strategies that can be implemented to make the waiting time seem more manageable. Some of the things that can occur or can influence the quality of waiting experience is that occupied time feels shorter than unoccupied time. So waiting customers who have something to do are going to feel as if the time is shorter than those who do not have anything to do. Anxiety makes the wait seem longer. So if there's anxiety about making it on the last ferry or just how long that may be, will decrease the quality of service that they are receiving. Uncertain wait times are longer than known, and finite waiting times, so just knowing how long the wait will be is helpful. Unexplained waits are longer than explained waiting times, so if we can explain the cause of the waits, that will help. And unfair waits are longer than equitable waiting times. To help us quantify the waiting times, we collected data. The data were collected from 6:30 a.m. on June 11th, 2015 to 5:30 p.m. on June 13th, 2015. Cameras were installed to record vehicles as they queued, so they can then later be counted and classified by time of day across the days that were collected. The queuing location at the Hatteras Terminal is a series of lines that can be filled and refilled as the ferry vessels are loaded. On Ocracoke, and we'll see images of these later in the presentation, on Ocracoke it is a single line. At Ocracoke, because it's a single line, there were periods in the peak portion of the day on June 11th in the afternoon that were not recorded because the line was too long to be seen where the cameras were positioned. The final count of vehicles that were observed was a total of 3,340 vehicles. 1,491 of the vehicles were at the Ocracoke Terminal, and 1,849 vehicles were at the Hatteras Terminal. And we have results from each terminal. So starting at the Hatteras Terminal, our x-axis here is the time of day. So starting at 6 a.m. and going through 11 p.m. Our y-axis is the queue length. Our primary y-axis on the left side is the queue length. And so these are tied to the bars. So we can look at the bars for Thursday, Friday, and Saturday by the time of day. And we need to tie those back to the left axis so we can see the longest queues occurred on Thursday at the Hatteras Terminal, and those tended to be in the earlier part of the day. So the peak queuing time periods were from 9 a.m. to approximately 1 or 2 p.m. The other days, Friday and Saturday, were much lower. The lines represent the average time in queue, so that should be compared or quantified by the vertical axis on the right, so the right side vertical axis. And again, this is the average time in the queue for vehicles. And we see those do have a correlation with the queue length. So during the peak periods on Thursday, these users could expect a wait time of approximately 90 minutes. We have a similar set of information for the Ocracoke Terminal. It looks much different than the Hatteras Terminal because typically, especially people coming for day trips, will leave Hatteras in the morning, and that's why we saw the peak in the morning, and then they'll return back leaving from the Ocracoke Terminal in the evening. So we see that peak is much more spread at the Ocracoke Terminal, but we also see that it's towards the evening hours. And we can see the queue length represented by the bars. We can see the values from the left vertical axis, and for the average time in the queue, looking at the lines, we can see that from the right vertical axis, and as they vary from the time of day. The maximum queue length was approximately 85 vehicles that occurred at 4 p.m. on Thursday. As I mentioned previously, the traffic line was too far to see with our video cameras that were installed from 5 through 7 p.m. So that queue length was likely much longer than the 85 vehicles that are shown in this graph. And the average wait time got up to a maximum of approximately 70 minutes on the last sailing of the day. And that's partially because there was a break between the second to the last and the final sailing of the day. Another way to view the results of this study is looking at the queue position and the distribution of vehicles in the various queue positions and the average time in queue. So in orange we have the Ocracoke Terminal data, and in blue we have the data from Hatteras. The bars are tied to the cumulative percentage of vehicles on the left vertical axis, and the lines represent the average time in queue in minutes, which are shown on the right vertical axis. For the Hatteras Terminal, the median queue position is the 19th vehicle, and the median time in queue is 13 minutes. For the Ocracoke Terminal, those numbers are a little bit lower. The median queue position was the 13th vehicle, and the median time in the queue was 12 minutes. The maximum queue at the Ocracoke Terminal was 85 vehicles, which may be underrepresented based on the limitations of the video, and was 138 vehicles at the Hatteras Terminal. At the Ocracoke Terminal, approximately 25% of vehicles experienced a wait time of 30 minutes or greater, and that value was 40% at the Hatteras Terminal. So 40% of users at the Hatteras Terminal experienced a wait time of 30 minutes or greater, and a little more specifically, 20% of vehicles experienced a wait time of 70 minutes or greater, so that's a pretty substantial wait time. Vehicles arriving as the 15th vehicle in line experienced the least wait time before departing, and that is one interesting thing to see in this graph. Actually, the first people who arrive have a longer wait time than those who arrive in the mid-teens. So 15th is about the best time to arrive, and that's because if you're the first one who arrives, you probably are going to have some time to wait before the ferry departs. Really, in an ideal individual optimized system, you would arrive and be the last one to board a ferry that is about to depart. We can also look at the average number of ferries until departure. So we can look at the two terminals, Hatteras and Ocracoke, Hatteras being in blue, Ocracoke in orange here, and the days of the week are also represented by the solid or dashed or dotted lines. So what this can tell us is how likely a vehicle is by the time of day to board the first ferry or subsequent ferry. So ideally, the users would board the first ferry, and we see that's the case across most of these time periods, except for Thursday at Hatteras, particularly in the morning or early afternoon, and then Thursday later in the evening, leaving Ocracoke, coming back towards Hatteras. A total of 398 vehicles were present during the peak time at Hatteras, being classified as Thursday from 9 a.m. to 2:30 p.m. During that time, 37 vehicles, which represents 9.3% of the total, turned around and left the ferry terminal or left the queue. So these are people that might have been in the queue or arrived at the terminal, saw how long the queue was, and turned around. That estimate is fairly conservative because people could have turned around before they reached the field of view of our video cameras. And this loss of ridership does have an impact on visitor spending on Ocracoke. Much fewer numbers of people left the Ocracoke Terminal, only 3 vehicles, and that is likely because individuals on Ocracoke have a much longer distance to drive back to the village of Ocracoke, and if it's at the end of the day and they need to return to their residence or to the location they're staying for their visit, they'll need to board that ferry, so we would expect a lower number of turnaround vehicles at Ocracoke anyway. We can also just look at some average time, some descriptive statistics here, looking at each of the terminals and the average wait time for the ferry vessels boarded. So at the Hatteras Terminal, those who boarded the first ferry had an average wait time of 15 minutes, the second ferry 26 minutes, third ferry 50 minutes, and up to the sixth ferry. So individuals who boarded the sixth ferry after they arrived in the queue had an average wait time of 101 minutes, so over an hour and a half. At Ocracoke, we only saw vehicles who had to wait for up to 3 vehicles. The first, similar to Hatteras, was a 15-minute wait. Second, 28-minute wait. And for the third ferry, approximately 1 hour. Also, during the study, approximately 61% of vehicles at the Hatteras Terminal and 77% at the Ocracoke Terminal were able to board their first vessel. So most of the individuals who were using the ferry are in those earlier ferry vessel boarding rows. Based on this study, observations of waiting times and queue lengths were conducted at 2 terminals, Ocracoke and Hatteras. 2% of vehicles abandoned their trip overall. That was up to 9% in the peak periods, which results in an estimated loss of $375,000 in peak season revenue for Ocracoke businesses. If wait time information were provided to vehicular passengers waiting in line, this could help reduce the occurrence of people abandoning their trips, so we can possibly improve the waiting experience if there's some information about their wait time. This could be communicated through variable message signs, fixed signs, or pavement markers, or a combination of those. This study could also be expanded to result in more robust delay calculations by time of day, day of week, and month. And looking at some specific alternatives for the ferry terminals, this is the Hatteras Terminal, and multiple stacked lines are used. So here are stacked lines, and those are used to store the vehicles as they wait for the departing ferries, and this is where the ferries are as they are boarding. So in a situation with this, with multiple stacked lines, variable message signs are probably more appropriate, providing the flexibility and dynamic information to passengers either as they arrive into the queuing area or as they are stacked. So as they arrive, information could say you're approximately the 100th person in the queue, you have an expected wait time of a certain amount. Ocracoke Terminal is much more linear. So here's our ferry boarding location, and the queue storage wraps around this curve and then back down the highway. And in this scenario, static information, which could be signs or markings, could function because of the single file queue formation, meaning that signs could mark locations indicating that vehicles at this point are likely to experience a certain wait time before they board their ferry. This project was funded by the North Carolina Department of Transportation, so we appreciate the opportunity to support and cooperate with NCDOT, and we appreciate the information and knowledge provided to the research team by individuals, groups, and units. And we specifically like to thank Ed Goodwin and Jed Dixon for their guidance throughout the project, and the ferry staff at the Hatteras and Ocracoke terminals who facilitated our data collection.